This is where we are. All right. So solving systems of equations. I wrote on the top of it, a quick review. It's going to be quick, right? So we solved systems of equations semester 1, and we spent, I know in my class, we spent at least a month on it. Like, I think we spent 5 weeks on systems. Okay. So solving, the first one that we're going to use is the substitution method. We're going to solve using substitution. And what does substitution mean? Well, it means that you're going to get one variable all by itself, either x or y, and you're going to take the expression that you have left over. So like if you have an equation y equals 2x plus 4, you're going to take this expression and plug it in for y in the next equation and solve it. And then you're going to take that solution for x and plug it in and figure out y. Remember that all of your solutions to a system are what? Solutions to systems are ordered pairs. They are ordered pairs. They are x and y. So the first one, guided practice, we're just going to walk through it. We're just going to kind of talk through this one, okay? So here's our system. A system is just two or more equations with the same variables. So there's our system. Y equals 3x plus 2 and x plus 2y equals 11. So y is already all by itself. So I took this expression, 3x plus 2, right here, the expression, and I plugged it in for y in the second equation. So x plus 2 times the quantity, y is 3x plus 2, equals 11. Then I have to distribute. So x plus 6x plus 4 equals 11. Combine like terms, 1x and 6x is 7x plus 4 equals 11. I subtracted 4 from both sides and divided by 7. X equals 1. So I take that solution and I plug it back into one of the original equations, not something that you manipulated, one of the originals. So I plugged it into the first one. So y equals 3x plus 2. I'm replacing x with a 1. Y equals 3 times 1, which is 3. So y equals 5. So my solution is an ordered pair. If you don't write it as an ordered pair, it's not finished. It's not done. Your solution is an ordered pair. You will have an x and a y coordinate if you solve it right, okay? The other thing that I want you to remember is you can check these, right? You can check these. How do you do a check? Well, if your solution is 1, 5, you plug that in to the equation, plug it into both of them, and it'll give you a true statement. So y is 5 equals 3 times 1 plus 2. Well, 5 equals 3 times 1 is 3 plus 2 is 5. That's true. Let's check the second equation right here. Again, I'm checking with the ordered pair 1, 5. So the equation is x plus 2y equals 11. X is 1 plus 2 times 5 equals 11. 2 times 5 is 10 plus 1 is 11. And I taught my class how to do checks on a calculator. I think you should always check your solutions, but I would just check it on a calculator. Or just plug them into my calculator and make sure that I get what I'm supposed to. If you don't, if the solution that you got does not work for both equations, that means you made a what? Yeah, you made an error somewhere. Okay? Are we good with that? So I filled all of that out in your notes. All of that's there except the check. So we're going to do number 2 and number 3 together. We're going to do number 2 and number 3 together. Do you guys still need this? Doing the check? I'm going to leave that there for a second. We will do 2 and 3 together. Are we good? Can we go on? Okay, so number 2. So the first thing that we want to do is get a variable all by itself. So if you look at the 2 equations in our system, are one of these already solved for x equals or y equals? Yes, which one? Yeah, this top one says y equals 2x plus 5. So I'm going to take this 2x plus 5 and I'm going to plug it in for y in the next equation. I'm going to plug it in right there. So let's write that. So this equation right here now becomes 3x plus, but instead of y, I'm putting this in 2x plus 5. All I did was replace the y. I still have to finish off the equation, equals 10. Okay. So let's solve. Let's see. Combine like terms. 3x plus 2x is 5x. So I have 5x plus 5 equals 10. What am I going to do now? Subtract 5 from both sides. Subtract 5. We're solving for x. So 5x equals 10 minus 5 is 5. Now what? Divide by 5 on both sides. Yes, x equals 1. Good job, you guys. X equals 1. Are we done? No. Now we have to take this and solve for y. We have to figure out what y is. So do you want to put it into the first equation or the second equation? I would put it into the first, yeah, because once we manipulate it, we get y equals something. So let's put it into the first equation, which is y equals 2x plus 5. Okay, so I'm taking the value of 1. I'm replacing x with the number 1. So y equals 2 times 1 plus 5. That means y equals what? 7. Y equals 7. So my solution is the ordered pair 1, 7. My solution is the ordered pair 1, 7. I'm going to turn on I'm going to turn this on so you guys can see how to check it in your calculator because I want you to do that. So we're going to do a check in our calculator. So I'm going to shrink our screen up a bit and we're going to check this. So let's see. Our solution is the ordered pair 1, 7. So in my calculator, let's turn that around so it's not upside down and makes us all sick. So in my calculator, I am going to type in y equals, so y is what? 7. So whatever I do has to equal 7, right? So I'm going to type in, I'm checking the first equation. So 2 times 1, because x is 1, plus 5. And it better equal 7, because that's what y is. Is that what we get? It is. Okay. Now I have to check the next equation. The next equation says 3 times x plus y. So 3 times 1 plus 7. So I'm putting that in my calculator. 3 times 1 plus 7. And this one should equal 10. Whoops. Yeah. This one should equal 10. And it does. So I suggest you do the checks on the calculator, right? Do your checks on your calculator. You don't have to write them out. Just check them on your calculator. So this one's good. We did this one correctly. Let's do number 3. So look at number 3. So first of all, do any of these equations have x all by itself or y all by itself? It's not all by itself, but the first one does have x with a coefficient of 1. So it'd be easy to fix it, right? So let's get x alone. Let's get x alone for this equation. Let's see. So the equation is x minus 2y equals -6. What can I do to get x all by itself?
You add 2y.
Yeah, I'm going to add 2y to both sides. I want x to be by itself. I want it to say x equals. And so I get the equation x equals 2y minus 6. So this expression right here, 2y minus 6, is what I'm going to plug in to the next equation. I'm plugging that into the next equation, and I'm replacing the what value? The what value? The x. I'm taking this and plugging it in for the x. Okay. So 4 times 2y minus 6, that's what x is really, 2y minus 6, plus 6y equals 4. 4 times 2 is 8y. 4 times -6 is -24. Plus 6y equals 4. So we have to do some combining of like terms. What do you got for me, Austin?
Add 6 and 8 to give you 14.
Yeah, 8y and 6y give me 14y. So I have 14y minus 24 equals 4. I'm going to add, go ahead. It is a lot of 4s. I'm going to add 24 to both sides. So 14y equals 28. 14y equals 28. I'm trying to slide my screen up a little bit. There we go. Divide both sides by, and I find out that y equals 2. What do I do with that y equals 2? I have to plug it back into one of these equations. You want to plug it into the first one you said? I'm going to plug it in right here. So I'm going to rewrite that. I'm going to plug in y equals 2. So x minus 2y equals -6, but y equals 2. So x minus 2 times 2 equals -6. X, what is -2 times 2? X minus 4 equals -6. Add 4 to both sides, and x equals -2. So my solution is -2, 2. My solution is -2, 2. So if you wanted to check this in your Calci, check in your Calci, I'm just going to write what you would do. First equation, x is what? -2 minus 2 times what is y? 2. What should that equal? It better equal -6. Plug this into your Calci and tell me what you get. Plug that into your calculator and see what you get. I'm trying to slip it back down. What is going on there? Crazy, crazy. Okay. Anyone doing that on their calculator? -2 minus 2 times 2? No? No one's checking that for me? Did you get -6, CC? Awesome. Okay, let's check the second equation. Second equation says 4 times x. What is the value of x? -2 plus 6 times what is the value of y? 2. And this better equal what in my calculator? What better it equal? What better it equal? Yeah, I'm on the second equation. It better equal 4. That's what it says in my equation. It better equal 4. So check it. Tell me what you get. 4 times -2 plus 6 times 2. Do we get +4? I certainly hope so, or we've made a mistake. Okay? That is substitution. That is substitution. Okay? Number 4 and 5, I'm not going to do. I've already scanned the notes and I'll post them, but number 4 and 5, I'm not going to do. You can fill them out with the notes. You can fill them out with the scan notes. I'm not going to do them. We're going to jump to elimination. We're going to jump to elimination. Okay. Okay. So number 4 and number 5, I'm not going to solve those for you. I've already scanned them. I will tell you what the answers are if you want. The solution to this one is 0, -3. And the solution to this one is -2, -1. I'd like you to try them on your own. That might be bonus points when you do that, and I check it tomorrow, but we'll see. So we're going to jump down to elimination. Using elimination. Elimination is my favorite method. I like elimination so much better than substitution. It just makes so much more sense. I think that when I think about my class, like semester 1, we did so much better with elimination than we did with substitution, just because it makes sense. So this is basically how elimination works. You look at the two equations and you find the two variables that are the same, two x's or two y's, that have the same coefficient. Just one's positive and one's negative, right? And you add those together to cancel it out. You eliminate that variable. You just eliminate that variable. And then you solve as normal. So I'm going to walk us through the guided practice. So notice that I have a positive 2x and a negative 2x. They are the same variable, but they're opposites. Opposito, opposite. So when I add these two together, they cancel out. Cancelar. See? Does everybody see that? And then 3y plus 5y is 8y. 11 plus 13 is 24. Divide both sides by 8. Y equals 3. I'm going to take that value, y equals 3, and I plug it into the first equation, the original. 2x plus 3 times y, which is 3, equals 11. 2x plus 3 times 3 is 9, equals 11. I subtract 9 from both sides. I get 2x equals 2. Divide both sides by 2, and x equals 1. This, again, is my most favorite method because I just think it's the easiest. It makes the most sense for you guys. It's just kind of flawless, right? It just works well. So I already worked this one out with you. I just wanted to kind of talk you through it. So we're going to flip over to the next page, and we're going to do that guided practice. So flip over to the next page, and we're going to do this one right here. So I wrote hints on every single one of these problems. Okay? So when I look at these two equations right here, I do not have the same coefficient for my x terms. One's a 4 and one's a 5. I'm not going to be able to add or subtract those and get rid of them, right? So now I move to my y's. When I look at my y's, I have the same coefficient. They both have a 3. So if I take the first equation and leave it alone, I'm not changing the first equation. I'm leaving it just like it is. 4x, write this down, plus 3y equals 2. I'm not changing the first equation at all. The second equation, I wrote you guys a hint. It says multiply by -1. That means that I'm going to multiply every single thing, everything here, by -1. So -1 times 5 is, so I have -5x. -1 times 3 is -3, so that gives me -3y. -1 times -2 is +2. And now I'm going to take those two equations and I'm going to add them together. I'm going to add them together. 4x and negative 5x give me a negative 1x. A positive 3 and a negative 3 cancel out. 1x equals 4. Negative 1x equals 4 because 2 plus 2 is 4. Do we ever solve for a negative variable? No, we don't. Divide both sides by negative 1. X equals negative 4. Are we done? No, we have to find the y. So we're going to take this and plug in to find y. Which equation do you want to plug it into? The first one or the second one? It does not matter. The first one, so we're going to put it into this one. I'm going to rewrite it. So 4x plus 3y equals 2. So we're replacing the x with what? With what? With negative 4. So 4x is negative 4. So 4 times negative 4 plus 3y equals 2. 4 times negative 4 is negative 16 plus 3y equals 2. I'm trying to get y all by itself. What do I do next? Absolutely. I'm going to add 16 to both sides. Cancels out. 3y equals 18. Divide both sides by 3. Y equals 6. So my solution is negative 4, 6. My solution is negative 4, 6. So you guys choose. Do you want to do 4, 5, or 6 together? 4, 5, or 6 together? 6? Okay. Zach says 6. We're going to jump down to number 6. Again, my notes are posted. Okay. Do you want me to tell you what the answers to these are? Yes or no? Okay. So the solution to this one is 1, negative 1/2. The solution to this one is 5 over 3, negative 1. So those are the solutions. If you choose to solve them out, make sure you get those. Okay, it's good practice. Good practice, but I'm going to give you practice today. Number 6, we're going to do number 6 together. So what's the hint? What does it say we should do? Multiply by negative 1. We're not doing anything to the first equation, so I'm just going to rewrite it. 7x minus 2y equals 5. This bottom equation, I'm multiplying by negative 1. So negative 1 times 7x is negative 7x. Negative 1 times negative 3y is positive 3y. And negative 1 times positive 4 is negative 4. This one is so sweet. So I'm going to add these together. Add them together. So a negative 7 and a positive 7 cancel out. Negative 2y, positive 3y give me 1y. And 5 minus 4 equals 1. So that just says y equals 1. I love that. That's fabulous. So what am I going to do with that? Plug in to find x. Plug in to find x. So which one do you want to plug it into? The first one or the second one, guys and gals? Yeah, first one. So let's see. My first equation is 7x minus 2y equals 5. I'm replacing the y with the number 1. I'm replacing the y with the number 1. So 7x minus 2 times number 1, right? The y is actually 1, equals 5. So 7x minus 2 equals 5. What do you want to do next?
Add 2 to both sides.
Yeah, we're going to add 2 to both sides. So 7x equals 7. Divide both sides by 7, and we find out that x equals 1. So my solution is the ordered pair 1, 1. My solution is the ordered pair 1, 1.
So what was the solution to the first question? No. Oh, no.
So those are examples of using elimination where you don't have to change anything at all, or you just multiply by a negative to change the sign, right? But if you remember, there were also times where you had to multiply both equations, right? Sometimes you have to multiply both equations to get a common coefficient. So those are the 2 examples that I'm going to do next. I'm going to do those 2 examples next. Is everybody good with this? Okay. Turn it. So I'm going to walk through this one with you. I'm going to walk through it with you. So notice that I have to, first of all, put this equation in standard form. This equation right here needs to be put in standard form. So I did that. Because I have to be in standard form. So I had to move the x over. It has to be x plus y equals something. X plus y equals something. So now I have the negative 3x plus 2y equals 9. And I have this equation right up here that says 4x plus 5y equals 35. So I decided to change the x's. And I have to multiply them by a common, so they have a common coefficient, right? So I multiplied this top equation by 3. And that's what I'm doing right here. 4 times 3 is 12x. 5 times 3 is 15x. 35 times 3 is 105. Whoops, sorry about that. I take the bottom equation and I multiply it by a positive 4. Negative 3 times 4 gives me negative 12x. 4 times 2 gives me 8. So 8y. 4 times negative 9 is negative 36. The reason I do that is so that way I can cancel out my x's. Cancel out my x's. These cancel out when I add them together. 15 plus 8 is 23. 105 minus 36 is 69. Divide both sides by 23. Y equals 3. Okay, y equals 3. I take that y equals 3 and I plug it in right here. Plug in to find x. That's what I'm doing. I'm plugging it in to find x. So I replace the y with a 3. 4x plus 15 equals 35. Subtract 15 from both sides. 4x equals 20. Divide by 4, x equals 5. So my solution is 5, 3. Now I wrote hints and told you what to multiply for each one. I wrote hints out and told you what to multiply by for each one. Okay. And I also put them in standard form for you. Do you guys see that? I just went ahead and put them in standard form for you. So let's do number 2 together. And then we'll jump over and do your choice on the back, whatever you choose on the back. Okay, so number 2, I'm going to multiply the top equation by what? 5. And I'm going to multiply the bottom equation by 3. Okay, so here's how I do that. 5 times 3 is 15. So I have 15x. 5 times negative 7 is negative 35y. And 5 times 5 is 25. 3 times negative 5 is negative 15x. 3 times positive 9 is positive 27y. And 3 times 5 is 15. 7.
No way, it's like parallel.
It's not parallel. When I add these two together, this cancel out. Negative 35 and positive 27 give me a negative 8. Negative 8y equals 25 and 15 is 40. Divide both sides by negative 8. Y equals negative 5. What do I do with that y equals negative 5? Yeah, I have to plug it back in to find the x. I have to plug it in to find x. So I'm going to plug it into that first equation. 3x minus 7y equals 5. 3x minus 7 times negative 5 equals 5. 3x plus 35 equals 5. Subtract 35 from both sides. 3x equals negative 30. Divide both sides by 3. X equals negative 10. So my solution is negative 10, negative 5. I'm going to shrink that up for a second. I'm going to leave it there so you can still see it. And I am going to pull something up to remind you something that you know. What do you guys know about systems? Their solutions do what? If there is a solution to the system, what does that mean? There's a solution to the system. That means this ordered pair right here, this ordered pair right here is the place where these two lines do what? Intersect. Yeah. So probably 2 or 3 of the questions on your test may require that you solve it algebraically. But most of them are going to let you solve it using whatever method you want. Okay? Most of them are going to let you solve it choosing whatever method you want. So why would you not just plug it into Desmos? Right? And let Desmos solve it for you, right? Desmos graphing. You get Desmos graphing is built into your test. If it part of your test is no calculator, and part of it is calculator, right? So the first part is no calculator. So the no calculator part, you don't have Desmos, but for the calculator part, you do. You have a handheld calculator and Desmos. I would plug every single thing into Desmos. You know what I mean? And let it do the thinking for you. That's why we teach you how to do that, right? Histograms, box plots, any kind of scatter plot, any of that stuff, I would use Desmos. Let it do all the work for you. So there's your solution. That's another way to check, right? I just wanted to show you that you know that we did that, right? So use that method. Use that method when you're doing your homework. Practice 1 or 2 of them, make sure you know how to do it, and then use that method, okay? So do you guys want to do one more on the back, or are you good? So I will do as many as you need. 4, 5, 6. 4, 5, 6. Do you want to see one of them? 5. Okay. Number 5. If you don't want to write it down, don't write it down. They're posted. The answers are posted, but I'm going to do it with you. So this first equation is going to get multiplied by 2. 2 times 9 is 18. So I have 18x. 2 times negative 8 is negative 16y. 2 times 4 equals 8. Negative 9 times 2 is negative 18x. Negative 9 times negative 3 is positive 27y. Negative 9 times negative 4 equals 36. I'm doing number 5. Do you see where it says number 5, your turn? I'm going to add these together. The positive 18, negative 18 cancel out. Negative 16 and a positive 27 give me 11. 36 and 8 give me 44. Divide both sides by 11. Y equals 4. I'm going to take that and plug it back in to find x. going to use the first equation. 9x minus 8y equals 4. Remember, I'm plugging in for y, so 9 times x minus 8 times 4 equals 4. 9x minus 32 equals 4. Add 32 to both sides. 9x equals 36. Divide both sides by 9. X equals 4. So my solution is 4, 4. My solution is 4, 4. The solution for number 6, if you guys are going to work that out, is the ordered pair 5, 6. The solution for number 6, if you're going to work it out, is the ordered pair 5, 6. And the solution for number 4, if you want to work that out, is -7, -12. Number 4 is -7, -12. -7, -12. -7, -12. Okay. I want everyone to look at the last page because this is important. This is important. Okay. Last page talks about solutions. So remember that when you have a system that has one solution, that means that the lines intersect at exactly 1 point. The lines intersect at exactly 1 point. Do you guys see that? That means it has one solution, and it's called consistent independent. Consistent means they intersect. Independent means the lines are unique. They're not the same line. How do I recognize those? The slopes are different. The y-intercepts could be the same. The slopes are different. That's what's important. The slopes are different. If the slopes are different, they're eventually going to intersect. That's all you need to know. Okay? We also learned about no solution. What kind of lines are these? Yeah, they're parallel. When the lines are parallel, that is called inconsistent because they do not intersect. If consistent means they intersect, inconsistent means they don't. What do we know about that? Parallel lines have the same slope, different y-intercepts. That's how we recognize those, okay? And then sometimes you get something crazy that has one line with one crazy equation and another line, and when you solve them and graph them, both lines end up stacked right on top of each other, right? Both lines, that's two lines stacked right on top of each other. That means you have infinitely many solutions. Those are dependent. Slopes are the same, y-intercepts are the same. Okay? So we're going to look at these two types of equations, and it says without graphing, tell me what kind of solution is it going to give you? One, none, or many. So let's look at this. What is the slope of this equation? The slope is 3. Let's see what the slope is of this equation. So hang on. I'm going to add 6 to both sides, right? Add 6x. So 2y equals 6x plus 4. So I have to add 6x. I have to get it solved for y. And then I divide both sides by 2 every term. Y equals 6 divided by 2 is 3, right? So what is the slope of this line? They have the same slope. What does that mean? They're parallel, which means what? The lines will never intersect, which means no solution. Yeah. This is an example of no solution. Same slope. Hang on a second. What is 4 divided by 2? So they have the same slope, and what else? Same y. So what is this really? This isn't no solution. What is it? Yeah, this is infinite. Do you guys see that? I was waiting for someone to correct me, but same slope, same b's. B equals 2, b equals 2. Same slope, same b's. Infinite, infinite, infinite. Here, when you solve for your slope, you get 2 divided by 4, which is 1/2. 2 divided by 4. Here, when you solve for your slope and your y-intercept, is like 3/2. B equals 3/2. Here, when you solve for your slope is 4 divided by 8, which is 1/2, and your y-intercept is -3/2. -3/2. Same slope, different y-intercepts. No solution. Okay, I'm going to freeze that and leave those there for a second. Again, I scanned these and I will post them. No solution because the lines are parallel. They're never going to intersect. Okay, again, what could you use to graph these or check these? Desmos, Desmos, Desmos. Use Desmos. If you graph 2 lines, if you put 2 equations into Desmos and it only gives you 1 line, that just tells you that those lines did what? Smacked right on top of each other. Okay, tells you that those lines smashed right on top of each other. Okay,